According to the sewerage meter plan of Dhaka WASA, Dasher Kandi sewage treatment plant among 5 sewage treatment plants was planned. And to implement Dasher Kandi STP project, the EPC turnkey contract was made between Dhaka WASA and Hydro China Corporation on August 30th, 2015 year, and entrusted the implementation to Power China Chengdu Engineering Corporation Limited. Dasher Kandi sewage treatment plant is located in the eastern area of Dhaka, the capital of Bangladesh, mainly treating domestic sewage from Gulshan, Banani, Hatir Jheel, Bada, Aftab Nagar, and Dasher Kandi area in Dhaka city. The Dasher Kandi sewage treatment plant consists of 4 major parts. They are the sewage lift station of 6 cubic meters per second, sewage conveyance pipeline of 4.8 kilometers length of double GRP pipes, sewage treatment plant of 500 MLD, and sludge dry and incineration plant of 540 cubic meters per day. The SLS is located at the west side of Rampura Bridge, and it is the first treatment facility for Dasher Kandi STP project. The sewage flows into the SLS from an overflow inspection well at the end of the current sewer network and passes through coarse screen to flow into the pump station. The large solid waste will be intercepted and removed by coarse screen. Then the sewage is lifted up by sewage submersible pump and goes into the SCP. The SCP is parallel twin pipeline with total length of 4.8 kilometers. It is laid along with Aftab Nagar Housing Society. The SCP conveys the sewage coming from the SLS at Rampura by gravity flow. In the meantime, it collects also domestic sewage from nearby communities along this pipeline. STP and SDIP, as one integrated plant, are located in Dasher Kandi village area from the eastern side of Gojaria Canal. The plant is divided into 3 areas based on their respective function, including the sewage treatment area, sludge treatment area, and plant management area. The sewage treatment area includes inlet pump station, coarse screen, fine screen, vortex grit chamber, primary sedimentation tank, AAO tank, secondary sedimentation tank, ultraviolet disinfection tank, and effluent sampling chamber, etc. The inlet pump station is the first treatment unit of the STP. The sewage goes through coarse screening for removing some remaining large solid waste materials. Then the sewage will be lifted up and then goes through fine screen channel for further interception and removal of solid waste particles. Then, 80% inorganic particles are separated from the sewage by the vortex grit chamber. After the grit and water separation, the sewage is conveyed by gravity to 2 distribution tanks and evenly distributed to 4 primary sedimentation tanks. The PST is a circular tank with water inflow from the center and outflow from the periphery. Its function is to effectively eliminate suspended solids and partially remove organic pollutants from sewage. 1 perimeter drive sludge scraper is equipped in each PST to collect the suspended solids settled on the bottom of the tank, which is called primary settling sludge. Primary settling sludge will be pumped to the sludge storage tank for temporary storage. And the upper sewage of the PST will flow into the AAO tank by the connecting channel. The STP is equipped with 4 rectangular AAO tanks. Each of them is divided into 3 distinct zones, which are anaerobic zone, anoxic zone, and aerobic zone, whose function is to further remove phosphorus, BOD, ammonia nitrogen, suspended solids, and other pollutants in sewage by activated sludge. AAO tank is a key process section of biochemical system. Typically, the main control process parameters are dissolved oxygen and mixed liquor suspended solids. The activated sludge mixture of AAO tank is evenly distributed to the circular secondary sedimentation tank by equalization tank. The SST is to precipitate the activated sludge mixture from the AAO tank and finally achieve solid-liquid separation. The sludge is precipitated to the bottom of the SST by gravity and collected by the sludge suction machine. Then the sludge will be transported to the sludge storage tank and the AAO tank respectively. The supernatant, as treated clean water, outflows from the 3-angle weir in the SST and inflow to the ultraviolet disinfection tank treatment unit. Ultraviolet disinfection tank is the last treatment unit of the sewage treatment system, and its function is to eliminate bacteria and viruses from the water body by exposure to ultraviolet radiation. After being sterilized by ultraviolet light, the treated clean water flows into the effluent sampling chamber. 8 treated water quality indicators, including pH, COD, BOD, total nitrogen, suspended solid, phosphate, and fecal coliform, will be kept on monitoring and testing to make sure that the treated water quality meets the contract requirement. Then the qualified treated water will be finally discharged into the Gojaria Canal. The sludge treatment and disposal area is arranged in the north of the plant, including the sludge storage tank, sludge thickening and dewatering building, sludge cake storage tanks, and sludge drying and incineration plant from the west to the east. The sludge thickening and dewatering building mainly gives treatment to the sludge discharged from both PST and SST. Firstly, rotary drum thickener is used to concentrate the mixed sludge, and the concentrated sludge is transported to the dewatering unit. Horizontal centrifugal dehydrator in the dewatering unit is utilized for sludge dehydration till getting the sludge cake to a moisture content of 78%. Then the sludge cake will be pumped to sludge cake storage tank by sludge screw pump for further processing in the SDIP. The sludge drying and incineration plant adopts the patented technology independently developed by Tsinghua University, which is one technology for the disposal treatment process combining sludge spray drying and rotary kiln incineration. This technology aims to that the sludge is directly dried by high-temperature flue gas in the drying tower to achieve efficient and safe heat energy recovery and utilization, and to save fuel consumption as well. The slag after the sludge is completely burned can be reused as resources. SDIP is equipped with sludge drying and incineration system, which has a rated capacity of 270 cubic meters per day for the 78% moisture sludge cake. The plant is mainly composed of sludge cake storage and convey system, sludge drying system, sludge incineration system, and flue gas purification system. The sludge cake storage and convey system includes 2 sludge cake storage tanks and 2 sludge intermediate storage tanks, with a total storage capacity of 4,200 cubic meters. The sludge drying system includes 2 sludge drying towers and 10 sets of sludge sprayers. The high-temperature flue gas, discharged from the secondary combustion chamber, enters into the spray drying tower and keeps the temperature in the range of 550 to 650 degrees Celsius. The atomized wet sludge forms droplets under the action of high-pressure air by the sprayer, and then the wet sludge gets drying by absorbing heat from high-temperature flue gas, decreasing the water content of the sludge from 78% to 20% after finally entering into the sludge incineration system. Sludge incineration system consists of rotary kiln, secondary combustion chamber, rotary kiln oil fuel burner, secondary combustion chamber oil fuel burner, etc. The temperature of the secondary combustion chamber is controlled above 850 degrees Celsius, and the residence time of the flue gas in the secondary combustion chamber is more than 2 seconds. After the drying sludge is completely burned in the rotary kiln, the remaining slag is transported to slag storage tanks with the volume of 350 cubic meters. The slag is finally sent to the cement plant for resource recycling. The flue gas purification system includes cyclone separator, bag filter, activated carbon tank, spray tower, chimney, and ozone generator system. After the flue gas goes through the bag filter, the dust in the flue gas can be effectively removed. The activated carbon is sprayed in the bag filter to absorb the harmful substances such as heavy metals and dioxins, and the ozone generator system can eliminate the odor in the flue gas. The 3-stage alkali spray tower can wash away the acid gas in the flue gas. After the flue gas purification process, the pollutant in the flue gas includes particulate matter, NOx, sulfur dioxide, hydrogen chloride, carbon monoxide, hydrargyrum and its compound, cadmium, thallium and their compounds, dioxin family, can be effectively controlled within the emission standard. With the online real-time monitoring and the third party's periodical testing, the final emission quality of the purified flue gas can be well controlled. The plant management area includes office and control building, repairing and storage building, reclaimed water and fire water pump house, electrical rooms, etc. Office and control building is equipped with advanced laboratory facilities and a central control room having PLC-based SCADA system. The laboratory enables timely daily testing for the plant and provides an accurate reflection of water quality indices for both inflow and outflow. There are 3 modern central control rooms designed in this plant, respectively situated at the sewage lift station, office and control building of STP, and sludge dry and incineration plant. The central control room is equipped with an advanced automated control system and a high-definition video monitoring system, which are utilized to assist operators in remotely monitoring each equipment and instrument. Additionally, the systems enable high-speed data and signal exchange with all field equipment and instruments. Therefore, the operator is able to directly observe and detect the equipment status in the field from the CCR during system operation, significantly enhancing the automatic control capability and providing a reliable guarantee for the stable operation of sewage treatment plant. Dasher Kandi Sewage Treatment Plant in Bangladesh is the largest modern sewage treatment plant built in South Asia, as well as the first large-scale municipal sewage treatment plant in Bangladesh. It integrates sewage water treatment system and sludge treatment, and final disposal system in place at one time. The completion of Dasher Kandi STP project has significantly enhanced the water quality of Rampura Canal in Dhaka City.